Here is how you can break a crypto wallet. Getting the secret key to a wallet would give you complete access to all the cryptos and tokens in that wallet. It's logically not that hard, but practically nearly impossible. Wallets have both a public and private key. It's the private one that we're really after. If you own the key, you own the wallet and everything in it. There is no logic or calculation that will bring you from the public to the private key. But we can make random guesses and check whether we guessed correctly. Let's walk through the code that could return the private key. Next, I will show you the unbelievable amount of time and energy it takes to achieve it. Let's open our VS Code. Create Python files. Get the script from the author GitHub. On GitHub, look for the edu break wallet repository. You'll find both files in there. You will see I've already entered a wallet address. You can find it on BTC Scan. This address has tons of Bitcoins. Remember, the owner of the wallet is the holder of the key. We are trying a brute force tactic. This means that we accept that there is no real logic behind getting the private key, and we obviously don't want to use any social engineering. So we will just keep on guessing keys until we are right. The idea is that we have a given wallet address full of Bitcoins. To guess its private key, we will go through the steps of creating a new private and public key, applying some cryptographic steps to finally get a new wallet address based on our newly created keys. If this new wallet address is the same as the one we are looking for, then great. If not, then we will repeat all the steps over and over again. Before running the script, let's walk through each section so you understand what's happening. We call our brute/force/attack function. Here we will loop until our new wallet equals the given wallet or until we have reached our maximum number of attempts. First, we turn our private key number in a 32-byte sequence. Next, we call the function where all the interesting stuff is happening. Here, we first create a private key. This is converted into an elliptic curve signing key. Then, we create the public key based on our private key. Adding \x04 indicates that the public key is uncompressed. Then we hash the public key with two algorithms. Then we add the network byte \x00 to indicate we're on Bitcoin mainnet. Then we calculate the checksum. And finally, we get the new Bitcoin address based on the keys we've just created. We give the private key, public key, and wallet address back to the previous function. Back in the brute/force/attach function, we compare the new wallet to the given wallet, and that's it. If we are lucky, then it's match. And we will have the keys. Let's all cross our fingers. Let's run it. Not today. Sadly, it will never happen. The odds are so small that using every existing computer on the planet wouldn't even come close. If you don't believe me, let's take a look at the probability script. A 256-bit key provides a 2 to the power of 256 possible combinations. This means that the number of the possibilities is 2 to the power of 256. It's hard to grasp what it means. Let's calculate and look at some big numbers. The script attempts to calculate the number of possible private keys, the number of years it will take to break it, the amount of energy it will take to break it. All assumptions can be debated, but it doesn't really matter. Let's run it. The number of possibilities is a 1 followed by 77 zeros. Here are the years and energy that you would need. And if we would use all the energy that we have in the world just to break this one wallet, then the number of years it will take is a 6 with 50 zeros. I hope you found this explanation interesting. If you would like to support this channel, consider grabbing some Alpshire tokens. Your support means a lot. Thanks for watching and see you next time! If you want to create your own token for free, then watch the next video. Toot, toot, toot.